done is... Oh, should we say what we're representing first? Basically, it's representing like the sediment that's deposited on the seabed and then formed into layers of rock, kind of. And then basically what we've done is we've got salt and we mixed it with water to make it like kind of joined together, and it's settled in layers.
Being a cycle, the rock cycle doesn't have a particular beginning or end, but we'll start with the magma deep below the Earth's crust.
Oh, I'm hot.
Irregularities in the Earth's crust can cause the magma to rise. Some of it cools below the Earth's surface and creates igneous rock with large interlocking crystals, like granite. Some of the magma cools quickly above the surface with small interlocking crystals, like pumice. Rock above the surface of the Earth's crust can be weathered by either chemical or physical weathering.
Oh, crash.
When being carried by rivers and streams, rocks can bump into each other, knocking off sharp edges. The broken bits of rock are deposited when the river or stream loses energy. And over millions of years, the rock is deposited on top of it, causing the water to be squeezed out between the grains, making them become cemented together. The igneous rock has now become sedimentary rock. Over time, more and more sediment is deposited above the rock, causing it to go down to the Earth's extremely hot core. The extreme heat and high pressure transforms the rock into metamorphic rock.
Transformers!
As the buildup of sediment increases above groove, it gets pushed further towards the Earth's core. The extreme heat causes the rock to melt and become magma again.
So in this test tube there's different sediments. There's dough, crushed up biscuit and pipe cleaner, but it hasn't turned out well. It's all cemented together by honey, which is in here, this yellow stuff. And when it's deposited, it compacts each other. They compact each other, so I'm just squashing it down with this glass wad here. And then when it before it becomes metamorphic rock, it's heated. So it's put under pressure and mixed a little. Yeah, so now it's starting to
Metamorphic
burn.
into a
And
metamorphic rock.
crystallized.
Crystalline.
So if it's melted, what's it called when it's all melted?
Magma.
Oh, that smells nice.
And this
It smells like burnt,
and this magma is under the it's under
burnt toast with honey.
That's why I said.
this magma is under the rock and it's the form of molten rock.
I think it's good.
So let's turn it down now and let it cool down slowly to make.
Shall we turn the Bunsen off completely?
Yeah.
It represents how sedimentary rock can be formed by evaporation. So in this test tube we put some sugar and it's saturated the water, so this kind of represents like a sea. And so when we put it on top of the flame, the water will hopefully evaporate, and then all will be left behind is some sugar. Okay, so while that's like heating up and trying to evaporate, what's going to happen is all you're going to see once it's going to start to boil and bubble, and so it's going to like boil and bubble, and so all the water is going to evaporate away, and sugar is going to be left behind hopefully, and this process will happen over and over again until a significant level of sediment is built up. The sediments on top of the initial sediment will push down the sediment and kind of like cement it together, and so that will form the sedimentary rock. But then as sedimentary rock is pushed closer to the Earth's core, it will slowly like start to melt and form magma, which will show once this is evaporated. So. Okay, as you can see, the sugar's started to melt now, and it's like turned orange, so this represents the magma.
And if you leave it to cool, it will turn to crystals.
Yeah, hopefully. Yeah, okay. So then if we turn the fire off, it'll kind of cool down, and then okay. Due to uplifting, the magma is pushed towards the surface of the Earth, and then as it gets further away from the core, the heat level really reduces rapidly. And if it's pushed into a volcano and like shot out, it'll form extrusive igneous rock.
Like that.
But if it's only near to the surface of the Earth, it'll cool down slower, forming intrusive rock, which has larger crystals than the intrusive rock. So we're gonna take away the fire now and leave it to cool. And once it cools, it should form like a block of sugar, which will represent the rock.
So here we have like salt and some sand like in some water, and it's been like the water's been evaporating for like 10 minutes, and this represents like how the sediment is left because the water evaporates. So basically, here we have all the different sediments, like there's salt, sand, like massive stones, and some smaller stones somewhere inside. And we're going to see like how they're transported into the water. Hopefully the smaller sediments will go to here and the bigger ones will stay here.
Sorry.
So you can see like that. Yeah, we need a bit more. Yeah, you can see.
But it's showing it nice instead because it's taking away the small fragments, and look, it's leaving the rocks exposed, and that's how we get the rocks exposed. And
we're going to show how igneous rocks are formed. The bottle is the volcano, and the coke inside is magma, and when it comes out it will be lava. And now the volcano is going to erupt.
Woo! Exactly what?